Hello everyone, welcome to Excel Maths. So today we are going to be discussing question number 11 from June 23, pure paper 2. Let's get started. So we have a question over here. A tank is in the shape of a cuboid, as we can see. The capacity of the tank is 5 times 20 times 10, but the volume of the liquid is basically 20 times 10 times H. You can see. That is fine. So they have given all the, information over here. At time t, so the base of the tank is this. Do we need to write anything? At time t minutes after the water started flowing into the tank, the height of the water is h meters. That makes sense. So when you switch the tap, on and it has started filling, after some time, you've seen it is h meters filled. That's fine. And okay, so can we say that this H is basically, I'm doing it here, so volume of water, volume of liquid in the tank is going to be 20 times 10 times H. We can say 200 H, right? Meter cubed. Cubic meters. Volume is given, and what next thing is volume. They are saying use a cubic meters. That is fine. We are using that. In a model of this situation, the sides of the tank have negligible thickness. That is good. The rate at which, okay, it's not written at which there. The rate of change of V is inversely proportional to square root of H. Let's break this information. Decode this information. So whenever you get the change of V, that means it is dV, and the rate is basically nothing but dt. So this is basically dV over dt given to us. What it is, this line says dV over dt is inversely proportional, so 1 over. If we say directly proportional, so it's like whatever the value is there, but if it's inversely proportional, so 1 over the whatever the value they say. So they are saying square root of h. So let's write square root h over there. So overall, this is what we have. We have this information given to us. Let's copy that down. So V is 200 h and dV over dt is inversely proportional to square root of h. That is good. What we have to show? We have to show that dh over dt. So dh and dt. Does that make sense? Any sense? So probably you have h here and dt there. So let's, differentiate this thing. So if we differentiate this, we're going to be getting dV over dH. That is going to be 200. Correct? And over there, dV over dt is inversely proportional to 1 over root h. If we remove the inversely proportional sign, can we say that dV over dt is equal to k, some constant value, over root h? So we have taken some constant value. Whenever we remove the proportionality sign, we need to take some constant over there. Okay, so dV over dH is this. They are actually saying dH over dt. We are getting dV over dH. Just flip this one. Okay, if we flip it upside down, can we say that dH over dV is equal to 1 over 200? If that makes sense, why did we do this? Because it's dV here and dV there. If we multiply these two, if we just multiply these two, we're going to be getting dH over dt, and dV will be cancelled, right? So if you multiply, you're going to be getting dH over dt. That gives you 1 over 200 times, so times k over root h. Okay, that's nice. So it is something like what it was asking to prove. So we can say that dH over dt is equal to lambda over root h, where lambda is 1 over 200. Does that make sense? So we assumed lambda to be 1 over 200, k over 200 basically, k over 200. So this whole value can be written as lambda. Yeah, it's proved. So first part is done. Now first part is done. We need not to really check because it was to show. Now the second part, that's quite interesting. Given that, what is given that? What is given here? Initially. Initially meaning t is 0. When t is 0, the height of the water, the value of h is this. That's good. When t is 0, h is this. Shall we write it here? When t is 0, the value of h is 1.44 meters. Okay. Exactly 8 minutes after water started flowing. So when t is 8 minutes, the height of the tank, height of the water is 3.24 meters. Okay. So, and we have to write the, use the model to find out the equation linking h and t. So we have to write our equation in something, a form like this. So what we know, we actually have proved something. So A part is going to be helping us to solve B part. dH over dt, we have dH over dt, that is equal to lambda over root h, correct? And they are asking to write the equation in terms of h. So obviously you would be understanding from dH to h, it is integration. So let's rearrange things and integrate that. So if you cross multiply, you can write root h dH, that is equal to lambda dt, correct? And because we have to find out h, we are going to be integrating. Let's integrate that. So h, I mean, what it is, I'm doing it here. Root h is nothing but h to the power half. If you integrate that, so you are basically doing h to the power half plus 1. So what it gives, half plus 1 gives you 3 halves divided by whatever the value you have got. So 3 halves. That will give you 2/3 of h to the power 3 halves. So I'm going to write this value directly over there. So we can write 2/3 of h 3 halves, that is equal to lambda. When you integrate like 1 with something 1 dt, so it would just be t plus c. So it is lambda dt. So we're going to be getting lambda t plus c. So we have got this, equation in terms of h. Now what? We have some values given. At t0, we have h given, and at t8, we have h given. And if you can see, we have two unknowns in the equation. We have lambda and c unknown, which are represented as a and b there in the equation. So we are going to be substituting these two values in the equation so that we can find out lambda and c. And we are going to be substituting and making the equation looking like what they are asking us to do. So let's continue. So, okay, just give me a sec. Yeah, so let's substitute the value. First, we're going to be substituting t equals 0. So at t equals 0, so what will happen? This whole thing will be 0 only, and you're going to be getting the value of c. So c will be 2/3 of h to the power 3 halves, right? What happened? We are just substituting t0 in this equation. If you substitute t0, so this particular, red thing will be 0, lambda t will be 0, and we're going to be getting the value of c. As we know h, so where h is? Where h is here, we are going to be substituting. So c is going to be 2/3 of, use your calculator, Mr. Calculator. Wrong time for the call. Sorry about that. Okay. So yeah, I'm substituting the value. So 2/3 of thing in my calculator. That gives me, please bear with me. Let me quickly solve this. And it says 2/3 of 1.44 to the power of 3 halves, right? Oh dear, sorry about that. So it comes 1.44 3/2. I got 1.152. If you got the same. So C we've got. Now for lambda. For lambda, we are going to be substituting the value of C and H to find out lambda. So just substitute C and H. So I'm going to copy this thing there. Okay. And we will be substituting the value of C and H and T also. So T is 8, write 8. How is it? Lambda 8, it's better to write 8 lambda, no? 8 lambda here. And C was 1.152. What H is 3 point something, 3.24. 3.24. Okay. So please solve this. So I've got 3.24. That gives me this. Take away 1.152 divided by 8. Divided by 8. That gives me the value of lambda to be 0.342. Okay, 0.342. So we've got the value of lambda to be 0.342. Now what we need to do, we have C here and lambda here. Let's substitute there in the equation. So it's 2/3 H to the power 3/2 equals lambda is 0.342 T plus 1.152. It's not done yet. So H is H to the power 3/2. That is equal to 3/2 times 0.342 T plus 1.152. Okay, let's multiply quickly. So it is 1.5 times 0.342. That gives me, so it comes 0.513 T plus, let me do this as well, 1.5 times, what's that? 1.152. That gives us 1.728. So H to the power 3/2 is equal to this value, right? Let's quickly mark it, check it. It was question number 11, I guess. Yeah. Okay. So for question number 11, okay, here. Okay, 0.513 and 1.728. I think we've got something like this only. Yeah, that is correct. So we've got 5 big 5 marks. Very well done. 5 plus 3, 8 marks we've got. Now the last thing. Find the time taken from when water started flowing into the tank for the tank to be completely full. Okay, so hence that means we obviously are going to be, this is the basic GCSE kind of thing. Once you get hence, that means you have to take previous part, the help from. Okay, so over here, what is happening? The tank is completely full. So when the tank is fully complete, what the height will be? It would be H. Height means H. We have the equation in terms of H. Okay, so what we have to find? We have to find the time when your tank is going to be completely full. Okay, that makes sense. And yeah, that's quite obvious. They can make this part to be there. So they are saying the value of H is, indirectly they are saying the value of H is 5 meters. So we are smarter enough to understand, no, that tank is completely full. So it is 5. Okay, is 5 and we have to find out the value of T. So 5 to the power 3/2, that is equal to 0.513 T plus 1.728. Please use your calculator and do this one. I'm also using. So 5 to the power of 3 halves. I have written that. Take away, what we have to take away? 1.728, and this thing divided by 0.513. That gives me, am I correct? Hey, where the division sign is, sorry, that is divided by. Okay, so it gives me t equals 18.4256. so like I can say 18 point what 426 something. So minutes, I guess, no, because whole question was based on minutes only. T minutes, yeah. They could make it challenging writing seconds over here, but they didn't. They are sweet. Okay, minutes. Let's see if we are correct. Okay, we are correct. 18.4. Yeah, 18.4 minutes. Perfect. So hope you understand this. Thank you so much. Bye bye. Take care.